Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular video is OCR June 2023, Paper 3, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1, Part A. These four solids are labelled A, B, C and D. We've got a cube, we've got a cone, we've got a cuboid and a prism there with a hexagonal front. Write down the letter of the solid that is not a prism. Okay, well, a prism is just a shape which has got a uniform cross section, so it's the same all the way through. So this one is clearly a prism because it's got a hexagonal top and a hexagonal bottom that matches, and it's the same all the way through. But you could say the same thing about the cuboid, and you could say the same thing about the cube actually. The only one that isn't like that is the cone, because you know it's got like a tip here which is a point and then a circle at the bottom, so it doesn't match. Okay, so B is the one that is not a prism. B says these four triangles are labelled E, F, G and H. Write down the letter of the right-angled isosceles triangle. Well, a right-angled isosceles triangle is going to have a right angle in it, like that one does and that one does, but also it has two pairs of equal sides, which this one does and this one does. H has got three equal sides, that's an equilateral triangle, isn't it? So the one that has got both is G. It's got a right angle in it and it's got a pair of equal sides, so it's going to be G. Part C says a quadrilateral has exactly one line of symmetry and each angle is either acute or obtuse. Write down a possible quadrilateral on the grid. The dashed line must be the line of symmetry. Okay, so it's got exactly one line of symmetry. So I'm thinking probably the easiest thing to draw here would be a kite, because kites have one line of symmetry, don't they? So if I picked a point here and then maybe went down to here and then a longer side at the bottom, maybe down to here, look, that would have one line of symmetry. Okay, so yeah, it definitely has one line of symmetry running down the middle. There's no other line of symmetry I can place in there. And each angle is either acute or obtuse. Yeah, that one is obtuse, that one is obtuse, that one is obtuse, that one is acute. So yeah, they all match. Okay, so I've met all the conditions. I think I'm happy with that. Now that's not the only one you could draw, obviously. There's lots of different ones that you could draw. But as long as you just try and make sure it's only got one line of symmetry, that's probably the key thing. Question 2. The factors of 6 are 1, 2, 3 and 6, and the factors of 9 are 1, 3 and 9. Use one of the symbols less than, greater than or equal to make each statement true. Part 1 says the number of factors of 6 is that greater than or equal to or less than the number of factors of 9? Well, the number of the factors of 6, there are 4 of those, aren't there? There are 4 of those, and there were the number of factors of 9, there were 3 of those. So 4 is bigger than 3, so I'm going that way around. And then the lowest factor of 6 and the lowest factor of 9, well, the lowest factor of 6 is 1 and the lowest factor of 9 is 1, so they're actually equal to each other, aren't they? So those two things are the same thing. And then write down the highest common factor of 6 and 9. Well, the HCF is going to be the biggest common factor on both lists. I think that's the 3, isn't it? That's the biggest number that's on both lists there, so I'm going to write down 3. Question 3a, complete this prime factorization of 100. You may not need to use all of the answer lines. No, I'm not. I'm only going to use that little tiny bit next to it. So 100 is 2 times 2 times what? Well, you can actually just type this into your calculator, can't you? Because you've got a prime factor button on your calculator. If you type in 100 and then equals, then on the newest one, you then just press format and then you go down to prime factor and it will write it for you as a prime factor. So it's going to be, you can see on the screen, it's 2 squared times 5 squared. They've written it expanded form here. I'm just going to kind of copy that form a little bit more. So it's 2 times 2 times 5 times 5, isn't it? Part B says, a teacher says that the cube root of their favourite number is 5. Write down the teacher's favourite number. So if the cube root of the number is 5, then the number must be the same thing as 5 cubed then, isn't it? Which is 5 times 5 is 25 times 5 is 125. So 5 cubed is 125. Write down 29 over 10 squared as a percentage. Well, 10 squared is 100, so it's already as a fraction over 100. So that's just 29%. It's an easy question. 29%. Question 4a, a recipe for biscuits says multiply the number of biscuits by 6.25 to find the number of grams of butter needed. Darcy uses 125 grams of butter. How many biscuits does Darcy make? So if you have to multiply the number of biscuits by 6.25 to find the number of grams of butter needed, that means for every 1 biscuit you need 6.25 grams of butter then, don't you? So if I've then got 125 grams of butter, how many biscuits is that then? Well, I think I need to just divide 125 by 6.25. How many times does 6.25 fit into 125? 125 divided by 6.25. It comes to 20. So it must be 20 biscuits then that they make. So that's 20 biscuits. All right. Part B says the estimated cost of driving an electric car is 68 pence per mile. A petrol car is 77 pence per mile. Charlie expects to drive 12,000 miles next year. Use this information to work out how much money Charlie can expect to save next year if driving an electric car instead of a petrol car. Okay. So what we're going to do is work out the cost. Well, we can do this in 2 ways. We can either work out the cost of the petrol car, work out the cost of the electric car, and then take away one from the other, or you can just simply take 77 minus 68 first and then use that number. I think that's what I might do. So I might do cost difference is per mile is going to be 77 minus 68. So that's equal to 9p. So if he's saving 9 pence per mile for 12,000 miles, then the cost saving is going to be 12,000 times 9p. What's that then? Well, 12,000 times 10 would be 120,000. Take away 12,000. That's 108,000 pence. But obviously we need this in pounds. So dividing it through by 100, that's going to leave me with 1,080 pounds. Question 5. This is a 1 centimetre square grid. On the grid, plot point A at minus 3, 3. Okay, so minus 3, 3. Minus 3 in the direction of x, which is 3 to the left, and 3 in the direction of y, which is 3 up. So minus 3 to the left, 3 up is the point here then. So that's my point A up there. And then B says the line AB joins point A to point B. Point B is that 2, 3. So where's 2, 3? 2, 3 is here, look. B. So let's just join those up. Let's get the line that they're talking about. Okay. What's the question? Find the length of the line. Well, how long is that line? Well, it's 1, 2, 3, 4, 5 units long, isn't it? So that's 5, and because it's a 1 centimetre square grid, that's just 5 centimetres, isn't it? No need to measure it. On the grid, draw the line x is equal to 2. Now, lines x equals a number are vertical lines, and they pass through the x-axis at that value. So the line x equals 2, that's going to be a line going straight up like that. Vertical line passing through 2. Okay, so that's the line x equals to 2. And then ABCD is a square that fits on the grid. Point C is on the line x. Find the coordinates of the point D. Okay. Well, if it's a square, all the sides are the same. So the side AB we already saw was 5 units. So down from B down to C, that's also going to be 5 units. So counting down 5, 1, 2, 3, 4, 5 is taking us to that point there, isn't it? So that's going to be my point C down there. Okay, so let's label that C. And then D then is going to be 5 units along, or, you know, down from A across from C. I think you can see it's there, isn't it? That's my point D there. Okay, so find the coordinates of D. Well, that coordinate is -3, -3, -2. Okay, so it's going to be -3, -2. Okay, now I don't really need to draw the square, do I? No, it just tells us that. So I've already found the coordinate. That's what I needed to do. Yeah, I think I'm done. Question 6a, part 1. What's 3a times 4? Well, when we've got things multiplied together, we kind of multiply together like with like. So I've got like 2 numbers and a letter. So I'm going to multiply the 2 numbers together. That's going to give me 12. And I'm just going to then add the a on the end, because I didn't end up doing anything with the a. So I'm just going to write down 12a. Okay? And then I've got b times b times b times b, b times b times b times b. These things are all the same, so I'm going to multiply those together. B times b is b squared, times b is b cubed, times b to another b is b to the power 4 then, isn't it? That's b to the power 4. C squared times c to the 4. Using laws of indices, you can just add those numbers together. It's c to the power of 2 plus 4. That's going to be c to the power 6. You can see it because c squared is c times c, and c to the power 4 is c times c times c times c. And if you multiply those together, look, you've got 6 c's in a row. So that's why it is what it is. It's c to the power of 6. And then factorize 9 minus 6y. When you factorize, you're going to put things into brackets. And what goes on the outside of the bracket, the things that's common to the 2 terms. So what's in 9 that's also in 6? Well, 9 is 3 times 3, and 6 is 3 times 2. So both of those contain a 3. So I'm going to write a 3 on the outside. And then 3 times what is 9? That's 3. 3 times what is 6y? That's going to be 2y then, isn't it? So that if you then multiplied out those brackets, you'd get back to 9 minus 6y, wouldn't you? So I'm pretty happy with that. So 3 lots of 3 minus 2y is the answer. Question 7. A student takes 2 tests. In test 1, the student scores 45. In test 1, the student scores 45 out of 60. Test 2 is also out of 60. Work out how many marks the student needs in test 2 to have a mean of 70% in the 2 tests. Okay, right, so it's going to have to do quite well in the second test, isn't it? Let's just work out what 70% of 60 would have to be then. Now let's work out how many marks in total are in the test. Total marks in test, that's going to be the 60 from the first paper and the 60 from the second paper. So the 2 papers are out of 120 marks. Okay, now what's 70% of 120? I just want to know how many marks he actually needs. So I'm going to do that as a percentage using final original multiplier. Stick your thumb on it. Okay, so the final is what I want to find. The original is 120, and the multiplier I want, it's this here, look, it's 70%, but 70% written as a decimal, that's going to be 0.7. So 70% as a decimal is 0.7. You just divide it by 100 if you're not quite sure where that came from. Okay, So yeah, so the original comes from here, the total marks in the test. So then final, which is the amount that he needs to get in both tests, is going to be the original times the multiplier from the triangle. Look, it's those two multiplied together. So it's going to be the original times the multiplier, which is 120 times 0.7, which according to my calculator, 120 times 0.7, that comes to 84. So that means he needs 84 marks in total in the two papers. Okay, so how many marks does he need in paper 2 then? If he scored 45 marks in paper 1, test 2 score must have been, the total he requires, which is 84 minus the 45 he got in the first test. So 84 take away 45, that is, what's that, 44, 39 marks. So that's how many marks he requires. He needs 39 marks. Question 8a, work out the area of this trapezium. Okay, well the formula for the area of a trapezium is a half a plus b times h. Essentially what you're doing is you're taking your two parallel sides, a and b, and you're averaging them. You're kind of adding them together and dividing by 2. Okay, that's what the formula is doing. So it's taking your a value 6, adding on the b value 9, 6 plus 9 is 15, and then we halve that to find the midway value between 6 and 9. So half of 15 would be 7.5, and then we times it by the distance between them. Okay, so the distance between them is this 4 here. You could ignore the 5, that's just there to scuba you don't need it. So yeah, we're going to times it by 4. So that's what we need to do. So half of 6 plus 9 times 4. Well, 6 plus 9 we said was 15. Half of 4 is 2. 2 lots of 15, that's 30. So I can work that out pretty easily without a calculator. That's just 30 centimeters squared then, isn't it? So that's going to be 30. Okay. Part B says the circumference of a circle in terms of pi is 100 pi centimeters squared. Work out the radius of the circle. Okay, so I've got two formulas that I need to remember for a circle. Cherry pie delicious. Apple pies are 2. It's a silly way to remember them. Which one of these do I need? I need the circumference this time, which is this formula here. The circumference of a circle is pi times the diameter. So we know what the circumference of this circle is. We've been given it, haven't we? So we know that if c is equal to pi d, and we know that that's 100 pi then, so 100 pi is equal to pi d, then can you see you've got pi on both sides? They're just going to cancel each other out. So that means the diameter of my circle is 100. So what's the radius then? So the radius is going to be the diameter divided by 2, because a radius is, so if that's the diameter, look, then the radius is going to be that bit there. It's half as long, isn't it? So it's 100 divided by 2, that's 50. Okay, and that's the answer that I need, 50 centimeters. Question 9, we've got a Venn diagram here. We're told the universal set is the numbers 1 through 13. Set T is 2, 4, 6, 8, 10, 12. They're the even ones. And then F is 5 and 10. Well, they're multiples of 5. And then the elements 1 and 2 have been entered into the Venn diagram. Complete the Venn diagram to show all of the elements. Now I like to put a little dot next to my elements so I know their elements are not numbers. It's a little bit of an old-fashioned thing, I guess, because they don't seem to want to do it these days on papers, but it just makes it clearer in my own mind that their elements are not the numbers of things in those parts. So what have we got? We've got the 2 down there already and the 1 outside. Now I like to start in the middle of the Venn diagram and then think about what goes in there first. So what's in T and in F? Okay, so if you have a look at what's in T and what's in F, you've just got one element there. You've got the 10. So that's going to go in this part here then, isn't it? So I'm just going to draw the 10 in here. Okay. And then I've got this number that's in F but not in T. So that's going to be in this section here. Don't know why I got this huge section here and I only got one number to put in it. Okay, but there's one little solo 5 in there. And then in the other set, I've got 2, 4, 6, 8, and 10. So that's going to go in T, the part that's in T, but not in F. So the rest of those numbers there need to go in here. So I've got a 4, I've got a 6, I've got an 8, and a 10. 10's gone, isn't it? And then 12. Okay, so then what's left? So we had 2, 4, 6, 8, and 12 we've already used. 10 we've already used. 5 we've already used. 1's already out. So I guess the rest then are going to go outside both circles then. So 1 I've already had. I've got to write down 3, 7, 9, 11, and 13. So they all need to go outside the circles, but inside the square. So 3, 7, 9, 11, and 13. They all have to go there. That's it. I think I've done all of them now. Right, and then part B says Finley picks one of the 13 elements in the universal set at random. Write down the probability that the element is a member of both set T and set F. Okay, well the only one that's in both is that 10 that's in the middle. So there's only one that's in both, and there's a total of 13 elements. So it's just going to be 1 out of 13, quite a simple probability one there. Part C says Sam picks one of the 13 elements in the universal set at random. Sam says the probability that the element is in set T is 6 out of 13. The probability that the element is in set F is 2 out of 13. Therefore, the probability the element is in set T or in set F is 6 over 13 plus 2 over 13, which is 8 over 13. Sam is wrong. Explain Sam's error and give the correct answer. Okay. Well, now, this is actually correct. It is that, and this is actually correct. It is that because there are 6 elements in set T and there are 2 elements in set F. The problem with what he's doing, just adding them together like that, he's double counting the one in the middle, this 10 here, because that 10 is in set T, it's part of the 6 out of 13, and it's also part of the 2 out of 13. So when they added them together, they've counted that one twice. Okay, so Sam's error is he has counted element 10 twice, as it is in both T and F. So what is the correct answer then? Well, if you have a look at the number of elements inside T and F altogether, you've got 1, 2, 3, 4, 5, and then the 10 we already counted 6 plus the 5, that's 7. So there are 7 of them altogether, isn't there? So the correct answer is going to be 7 out of 13. So you can add probabilities together, but only if your 2 sets are mutually exclusive. Okay, so if you've got probabilities, they have to be mutually exclusive probabilities, and here they're not mutually exclusive because 10 is in both. Question 10, write down 18 to 42 as a ratio in its simplest form. Okay, well, ratios cancel down the same way as fractions, so if you just type it in as a fraction into your calculator using the fraction keys, if I type in 18, hit the fraction key, and then 42 and press equals on my calculator, it's going to tell me that the answer is 3/7. Okay, so if 18/42 is 3/7, then the ratio of 18 to 42 is the same thing as 3:7 because they cancel down in exactly the same way. So even though there isn't a kind of a cancel down ratio button on your calculator, you can do it with the fraction key just as easily. B, it says in a bag of sweets, 1/5 of the sweets are green, the rest of the sweets are red. The ratio of the number of green sweets to the number of red sweets can be written in the form 1 to n. Find the value of n. Well, if I think about the ratio of green sweets to red sweets, I know that 1/5 of the sweets are green. So what fraction are red then? So if 1/5 are green, then the rest of it, 4/5, have to be red then, don't they? So timesing up those by a factor of 5, making both of those 5 times bigger, that means the ratio of green to red is in the ratio of 1 to 4. Okay, so I've got my green sweets in the ratio of 1 there, so my red sweets are going to be the value next to it. It's going to be this 4 here then, isn't it? So there have got to be 4 red sweets for every 1 green one. Part C, a factory has a large order for copper pipe. The factory has many machines that make the copper pipe. Each machine makes the same length of copper pipe in a day. 3 machines can make the copper pipe for this order in 25 days. Find the number of machines needed to make this order in 15 days. Okay. Well, if you've got 3 machines working for 25 days to make the amount of pipes that they need, so I kind of considered that to be the number of work units required. So if I've got 3 machines and they work for 25 days, then that is 3 times 25. That is 75 work units of work that need to be done, isn't it, if you think about it? Now, that's, I suppose you could think about it as that is 75 straight day work. It doesn't really matter. So if I then want to work out how many machines it's going to take to do that same amount of work in 15 days, then that is going to be, the number of machines is going to be the number of work units they need to do, which is 75, divided by the number of days you want to do it over, and that should tell me how many machines you need. So 75 divided by 15, that comes to 5. So that's 5 machines then, isn't it? So 5 machines. Okay. Question 11. The table shows 4 pairs of triangles. For each pair, decide whether the 2 triangles are mathematically similar. Write each answer yes or no in the second column of the table. Okay. Well, if they are similar, then all the angles have to be the same, don't they? Okay, and in the first one, I've got a 60 here and a 60 here. I've got a 50 here and a 50 here. And I've got a 70 here and a 70 here. So all the angles are the same. I'm happy to say that that is mathematically similar. Okay. Now, what about this next one? Well, as well as all the angles being the same, we could have all the sides in the same ratio. So if this is 6 and it goes with this 12, look, that is a factor of 2. It's twice as big. This one to this one is twice as big. This one to this one is twice as big. So all these sides are in the same ratio. They're all twice as big on the second one as they are on the first one. So again, these are similar. One is an enlargement of the other, isn't it? It's twice as, all the sides are twice as long, but that would mean all the angles are still the same. Then this one here, I've got 3, 4, 5, and I've got 5, 12, 13. Doubt in there, that doesn't look right to me. No, that's not similar. I can tell straight away, but you know, if you just think about, well, this 4 here, look, this one goes with this one, that's 3 times as big. 5 times 3 is not 13, so they're not the same multiple, so this one is a no-no. And then finally, I've got 2 angles that match, here and here, and I've got this one is twice as big as that one, and this one is twice as big as that one. Okay, now I'm going to say that these are the same because those angles are both the same, and I've got 2 sides either side of them the same. That would mean that these 2 here must be the same as well. This side and this side are going to be twice as big as well. So I'm going to say yes, that is true. It's a bit like an extension of the side angle side rule, isn't it? So if you've got like 2 congruent triangles, you can prove they're the same if you've got side angle side, 2 sides and included angle. And the same here, we've got 2 sides and an included angle that, you know, the angles match and the sides are in the same ratio, so the other side is also going to be in the same ratio. Question 12. A school has 540 students. This pie chart shows the way that all 540 students travel to the school. Each student either walked or cycles or travelled by bus or travelled by car. A. Work out how many of the 540 students travelled to the school by car. Okay, well the car you can see has got an angle of 72 there, look. What fraction of the full circle is that? That's 72 over 360ths of the full circle, because there's 360 degrees in a full turn. So if I work out that fraction of the total number of students that took part, that should tell me the number of students who travelled by car. So I'm going to type into my calculator 7 over 360, times by 540, and that gives me 108. Okay, so there were 108 students who travelled by car. Okay, the number of students who walk is 3 times the number of students who cycle. So that means 162 degrees is the angle for the people who are walking. So 162. Now you might just want to double check that. 162 plus 54 plus 72 plus 72 still adds up to 360. That might be a good visual check before you move on, but I think we're good. I think I'm going to move on. Question 13a. We're told that 2a is equal to the root of b, where b is a positive integer from 8 to 17. Given that a is a positive integer, find its value. You must show your working. Okay, so we know that b lies between 8 and 17, and if I square root it and get a positive integer, then what we're looking for b is a square number then, isn't it? So what are the square numbers between 8 and 17? There are only 2. 9 is a square number and 16 is a square number. So there are 2 possible candidates for b. So if I square rooted 9, square root of 9 is 3 and the square root of 16 is 4. But remember, we're looking for the value of a, and 2 lots of a are going to be equal to that number. Now if I said that 2a was equal to 3, then a would be 1.5. Now that's not a positive integer, okay, because it's a decimal. So that can't be right. So 2a could be equal to 4, in which case a was 2. That looks okay. So that's actually the only one that works, isn't it? So it has to be that a is 2. That's the only way. So 2a is 4 and the square root of 16 is 4, so they match. Part B says, how would your answer to part A change if a was only described as an integer? Well, there's not going to be any change because even if a could be a positive or negative number, b hasn't changed. B is still a positive integer, so the only positive integer solution to root of 16 is still only 4. So yeah, no change. Still only equal to 2. Question 14a. Sundip plans to share some money so that Mia gets a half of it, Sarah gets 2/5 and Nina gets 1/7. Will Sundip's plan work? Give a reason and show working to support your decision. Okay. Well, I'm quite curious what those 3 fractions add up to. I've got a sneaky suspicion they might actually be more than 1. So what I'm going to do is I'm going to add those 3 fractions together and see what I get first. So what is 1/2 plus 2/5 plus 1/7? It's the calculator paper. I'm not going to, break a sweat on this. I'm just going to use the fraction key to work this out for me. Don't be a hero. Let the calculator take the strain. So let's just type those in. 1/2 plus 2/5 plus 1/7. That comes to 1 3/70. 1 3/70 there, look. So that's too much. How can he give? He hasn't got enough to give away, is he? He's given out away more than the money he's got then. So I'm going to say, will Sundip's plan work? No, because the 3 fractions sum to more than 1, meaning he would be giving away more money than he has. Okay, that's probably longer than I need. But anyway, Sundip gives Mia and Sarah the fractions of the money that she planned. Mia gets £320. Work out how much money Sarah gets. Okay. So, if he's going to stick with the half and the 2/5 then, and we're told that Mia gets 320, that means that the total then, so if half of the total was equal to 320, then times in both sides by 2, then the total is going to be 2 lots of 320 is 640 then, isn't it? So that's how much he's sharing then, or he was sharing. So he's given Mia half of it. So what's 2/5 of it then? So I want to work out Sarah's fraction now. So 640 times 2/5, that's 256. Alex draws a bar chart to show the age of the young people attending a youth club. And we've got their ages along the bottom, 0 to 5, 5 to 10, 10 to 15, 15 to 20, and the number of young people, or the frequency up the side. Make one criticism of Alex's bar chart. Well, my criticism is that these bars here, they overlap, don't they? So you've got, if you're 5 years old, which bar are you in? Are you in the 0 to 5 bar, or are you in the 5 to 10 bar? Similarly, if you are 10 years old, are you in the 5 to 10 bar, or are you in the 10 to 15 bar? And so on. So I'm going to say the groups overlap, making it unclear where certain values belong. E.g., is 5 in the 0 to 5 group or the 5 to 10 group? Okay, I always write a lot more than the bare minimum that you need to get these marked, but I don't know. I like to be thorough. Question 16a. Write these numbers in order, starting with the smallest. Okay. Well, I think what I'm going to do is I'm just going to write them as proper numbers first, so I know how big they are. 2.4 times 10 to the 2. 10 to the 2 is in the hundreds. That's going to be 240. 1.3 times 10 to the 3. 10 to the 3 is the thousands, so that's 1,300. 4.9 times 10 to the minus 1. 10 to the minus 1 is in the tenths. That's going to be 0.49. And 9.5 times 10 to the 1, that's going to be in the tens. That's going to be 95 then, isn't it? Okay, so which one is the smallest? It's 4.9 times 10 to the minus 1. The next one is going to be 9.5 times 10 to the 1. The next one is going to be 2.4 times 10 to the 2. And finally, I've got 1.3 times 10 to the 3. Now, with these, you could have done it a lot easier. You didn't really need to convert them, actually. All you need to do, really, is look at these numbers here, which is the biggest one, okay? Because that gives you the magnitude of the number. So the biggest number is going to have the biggest magnitude. The smallest number is going to have the smallest magnitude. So just comparing those digits there is all you really need to answer this question. B, work out 5 times 10 to the 2 plus 4 times 10 to the 3. Give your answer in standard form. Well, I think I might just convert these both back into normal numbers, add them together and convert them back into standard form. I think that's probably the easiest, quickest way to do. So 5 times 10 to the 2. 10 to the 2 is hundreds, that's 500. And 4 times 10 to the 3. 10 to the 3 is thousands, so that's going to be 4,000. So if you add those together, you've got 4,500. So in standard form again, that's going to be 4.5 times 10 to the what? We just said, well, I just said 10 to the 3 is in the thousands. So it's 4.5 times 10 to the 3. Question 17. The number of people watching a football match is 30,000. Correct to the nearest 1,000. Complete the error interval for n, the number of people watching the football match. So n could be anywhere up to 30,500. They all, well, you know, well, 30,500 technically rounds up to 31,000. But notice you've got like a strictly less than symbol here. So one less than that would round down, so 30,499. And anything that is bigger than 29,500 is going to be the lower bound, then, isn't it? That all rounds up to 30,000 as well. So as the number of people watching a rugby match is 30,500, correct to the nearest 100, show that fewer people could be watching the rugby match than the football match. Okay. Well, what is the range for the rugby match then? So let's call that R. So R is going to be between, what are the limits for R then? So if it's 30,500 to the nearest 100, you know, imagine a number line. What's 100 more than 30,500? That's 30,600, and 100 less would be 30,400. So the ones that round to 30,500 are going to be the ones that are halfway between those or closer. So halfway between 30,400 and 30,500 is going to be 30,450, and halfway between those two is going to be 30,550. Okay, so then R could be any number between those. 30,450 and 30,550. So show that the fewer people could be watching the rugby match. Well, yeah, because we could have this number here for the number of people who watch the rugby match, and we could have something towards the upper bound of the other one, couldn't we? So I can say that we could have had 30,450 watching rugby, and we could have 30,451 watching football. Question 18, rearrange this formula to make K the subject. Okay, so these rearrange pretty much the same way as you're going to solve an equation. You have to do the same thing to both sides until you get K by itself. Okay, so at the moment I've got K times by 2 and then H subtracted from it. I'm going to add H to both sides. That's going to give me T plus H is equal to 2K. Okay, and then what I'm going to do is I'm going to divide both sides by 2. And that's going to give me, well, they're going to cancel, aren't they? Leaving me with K. K is equal to T plus H over 2. And that's my answer then. K is equal to T plus H over 2. A bag contains 150 counters. The counters are either red or yellow. Riley picks a counter from the bag, records its colour and replaces it. Here are Riley's results. So it's got 5 red and 4 yellow then on those tallies. Use Riley's results to work out how many red counters are likely to be in the bag. Okay, so he's got 150 counters in the bag, and out of 9 drawers, he's got 5 red. Okay, so the relative frequency of red is going to be the 5 reds that he got divided by the 9 draws he made. Okay, so that is the relative frequency we've got from the limited testing that he's done. Now, if I want to then know how many I would expect to get in the bag, then I'm going to assume that the number of reds then is going to be the number of counters in the bag times that relative frequency. I'm a bit miffed that 9 doesn't go into 150, so it's not going to be a nice number, but it is what it is. So 150 times 5 divided by 9, that's going to give me 83.3. So that comes out to be 83.3 to 3 significant figures. So I'm going to estimate, I'm going to round that down and say that there are 83 red counters, because you can't really have 0.3 of a counter, can I? So you're going to have to round it one way or the other. Seems sensible to round it down. 83. Part B says Ling uses the same bag of counters and picks the counters in the same way, and here are Ling's results. So Ling managed to get, what, 12 red and yellows. Well, that tally mark's fallen off, but that is 8, isn't it? Okay, so 12 tally marks versus 8. Use Ling's results to estimate the probability of choosing the red counter. So the same thing, relative frequency of getting a red this time is going to be the 12 reds out of the total of 12 plus 8, 20 draws, isn't it? So the relative frequency is 12/20ths. Now both those numbers are divisible, aren't they? Both divisible by 4, so I can divide them both by 4. And that's going to give me 3/5, then, isn't it? So then that is going to be the probability in its lowest forms or its relative frequency. It's going to be 3/5. Explain why Ling's results are likely to give better estimates than the probability of choosing a red counter from the bag that Riley's results. It's really just that Ling did the experiment more often. So he actually drew 20 counters, whereas Riley only drew 9. So he did more than twice as many trials. And the more trials you do, the better your estimate of relative frequency is going to be. So I'm just going to write that down. Ling conducted 20 trials, which is more than the 9 trials that, what's his name made? What's his name? Riley. Riley made. and so will be a better estimate. Okay. Question 20. New cars reduce in value once they've been bought. Zane buys a new car for £17,000. They see this table in a magazine. So you can see in year 1, the loss in value compared to the start of the year is 15%, and in year 2 is 10%. Zane says, according to this table, the value of my car will be £12,750 at the end of year 2. Show that Zane is not correct. Okay. So this is a percentage decrease question, but it's being decreased twice. So in the first year, in year 1, we've got final, original, multiplier. Final is what we're trying to find. The original is the cost of the vehicle, the new car, which is £17,000. And then the multiplier is the amount that it's going to go down by, isn't it? So if you start with 100% and it loses 15% of its value, that leaves you with 85%, which is 0.85 as a multiplier then, isn't it? So the final is what we're trying to find. So stick your thumb on that one. It tells me that it's the original times a multiplier there. So final equals original times multiplier. It's going to be 17,000 times by 0.85. What's that then? 17,000 times 0.85. That comes to, so that's 14,450. So that's the value of the car after year 1. And then in year 2, again, we're going to use final, original, multiplier. This time, still the final that we want to try to find. The original this time, though, is going to be the end of the price it was at the end of the first year, which was 14,450. And the multiplier for the second year, well, it's 10% here. So if you've got 100%, you take away 10%, then that's 90%, isn't it? Or 0.9 as a multiplier. So again, in year 2, final equals original times multiplier, just like before. And then this time it's going to be 14450 times 0.9. What's that then? Times 0.9, that's 13,005. So Zane says, according to this table, the value of my car will be 12,750 at the end of year 2. Well, I made it 13,005. So I'm just going to say price is 13,005. So Zane is not correct. Question 21. The length of a word is classed as short, medium, or long, depending on a number of characters in the word. The table shows the percentage in terms of x of each word length found in a book. Okay, so short words had a percentage of 2x plus 5, medium words had a percentage of 3x minus 1, long words had a percentage of x. Find the percentage of words in the book which are classed as short words. You must show your work in. Now, we can use the fact that every word in the book is classed as either short, medium, or long. So that means that these percentages should add up to 100%, shouldn't it? Okay, because that's everything. They're either short, they're medium, or they're long, and that's it. So all the words, all the percentages add together should add up to 100%. So I'm going to use that first to form an equation x, which I can then go on to solve. So 2x plus 5, which is the percentage of the short words, plus 3x minus 1, which is the percentage of the medium words, plus x, which is the long words. That should add up to 100, shouldn't it? Okay. So let's collect like terms. I've got 2x and 3x and x, and that adds up to 6x, doesn't it? So that's giving me 6x. And then I've got 5 and minus 1, that adds up to 4. So I've got 6x plus 4 is equal to 100. Taking 4 away from both sides, they're going to cancel, and that's going to leave me with 6x equals 96, which I hope is going to divide by 6. So dividing both sides by 6. That's going to leave me with x. X equals what? 6 is into 96. I think that's 16, isn't it? Goes in 16 times. So that tells me x is 16. So what do we want? We want to find the percentage words in the book which are classed as short words. So short words is going to be equal to 2x plus 5, but we just found that x is 16, so it's 2 lots of 16 plus 5. 2 lots of 16, and that's 32, plus 5, that is 37. So I make that 37%. Okay. The diagram represents a coastline. A, B, and C are lighthouses. A boat is the same distance from A and B, the same distance from AB and BC. Use a ruler and compasses only to construct the position of the boat. Label the position of the boat clearly. Okay, so we need to do 2 loci constructions here. Now, the same distance from A and B, what's that? That is the perpendicular bisector of A and B, isn't it? So we need to construct a perpendicular bisector of AB. That is the loci of that one. And the second one, the same distance from AB and BC, that is going to be the angle bisector. The angle bisector of angle ABC. So these are the 2 constructions that we need to make. Okay, so we're going to make those 2 constructions, and that should pinpoint where our boat is. Okay, so first off, to draw a perpendicular bisector of A and B, we're going to draw 2 arcs of the same aperture, one centered on A and one centered on B. That's going to give us 2 points of intersection when those 2 go down, and we can then join those up with a straight line with our ruler. Okay, so that means that our boat needs to be somewhere along that line. Now, obviously, it's not going to be on the land. It's not going to be in the grey bit. It's going to be in the white bit, the C part. Okay, so it's somewhere along that line. And the next thing we need to do then is to find the angle bisector of ABC. So what we do there, again, is we set our compass to a particular width. We mark on points on AB and BC, put the compass point at B, and cut AB and BC to find 2 marks, and then you put your compass on those 2 marks, and then you do a second set of arcs in the middle, and then you can join B to that cross that you made there. Okay, so the boat needs to be somewhere on that line as well. So given that it's on the angle bisector and it's also on the perpendicular bisector, we can see from that that our boat must be at this point here. Okay, so marking that on the diagram, what do we need to do? Label the position of the boat. Okay, so I'm going to write boat here. Okay, job done. It's at the end of each year, a driver records how many kilometers they have driven. In 2021, they drove 18% more kilometers than in 2020. In 2022, they drove 25% more kilometers than in 2020. In 2022, they drove 3,500 kilometers. Kai says, I can work out how many kilometers were driven in 2020 by reducing 3,500 by 25%. 3,500 times 0.75 is 2,625. Explain why 2,625 is not the correct number of kilometers driven in 2020. Okay, now the reason for this is I'm going to say that increasing 100% by 25% gives 125%, but decreasing 125% by 25% is not going to give you, is not 100% again. You don't get back to 100% because 25% of 125 is not 25, because 25% of 125. What's that then? So what's a quarter of 125? So 125 divided by 4, because 25% is a quarter, isn't it? That's 31.25 and not 25. Okay, so it's 31. You'd be taking off 31.25 rather than 25 away, so you're not going to get back to 100. So then part B says calculate the number of kilometers driven in 2021. So what I am going to do, I am going to have to go back to 2020 using the data I've got from the 2022 figure. So I'm going to find 2020 first by going back from 2022, and then I'm going to go forward from 2020 to 2021. Okay, so 2022 to 2020, final original multiplier for this using my triangle FOM. Now the final is what you got in 2022 because that came second, isn't it? And that's 3,500. The original is the thing we're looking for. That's the amount we had in 2020. And the multiplier here, it was a 25% increase. So that's 100% plus 25%, which is 125%, which is a decimal is 1.25. Okay? So then the original then is going to be equal to the final over the multiplier, isn't it? Covering up the thing you want to find in the triangle. Look, covering up the original, it's final over multiplier. So subbing those numbers in, that's going to be 3,500 divided by 1.25. What's that then? So 3,500 divided by 1.25. That's 2,800. Okay, so that means in 2020 there were 2,800 miles. So if I then do, I'm going to use this space up here. So if I then calculate from 2020 to 2021, that's like this bit of information here, isn't it? Then again, final original multiplier here. What have we got going on here? So final original multiplier. So the original then is the 2,800 that we just calculated. It's this number down here. Look, that's going to be my original amount from 2020 because I just worked it out, 2,800. Okay, now the final is what I'm trying to find, how much I had in 2021, and the multiplier I was given. The multiplier is over here, that is 18%. So 100% plus 18%, that's 118%, or 1.18 then, isn't it? Okay, so this time I want the final. So covering up the final tells me it's the original times the multiplier for this one. So final equals original times multiplier. So that's going to be the 2,800 from 2020 times the 1.18% increase. So 1.18 times 2,800, that comes to be 3,304. Okay, so that's the number of kilometers driven in 2021. So that's 3,304. The diagram shows the graph of y equals kx minus x squared plus 2, where k is an integer. Show that k is equal to 3. How am I going to show that k is equal to 3? I think what I'm going to do is I'm just going to pick a couple of points on the graph that are easy to read. So I'm going to pick this point here, which is 0, 2, because I know that lies on the graph. Maybe I'll pick this one over here as well, which is 3, 2. Okay? Now, if I sub those into the equation, they should be true, shouldn't they? So I don't know if I need one or both. Maybe I just need one. So if I've got y is equal to kx minus x squared plus 2, and I know then that y, it passes through that point I just picked off, which is at 0, 2. So subbing that in then, so 2 is equal to, now thinking about it, I'm not going to be able to use this limit because k is x is 0, and then my k term will disappear. So let's use the other one. Let's use it passing through 3, 2. So it passes through 3, 2. So 2 then, y value is equal to k lots of 3 minus 3 squared plus 2. So what's that then? So that's going to give me 2 is equal to 3k minus 3 squared is minus 9 plus 2 is minus 7, isn't it? So that's 3k minus 7. So that means 3k is 9, so k is equal to 3 then. That's right then. Okay, so k is equal to 3. And then use the graph to solve 3x minus x squared plus 2 is equal to 3. Okay, well, if k is equal to 3, then the graph we've got is y is equal to 3x minus x squared plus 2. Now, you'll notice that's the same as what we've got here. So basically we're saying when is the equation equal to 3? Okay, so when is y equal to 3? So where's y is equal to 3? Y is the straight line here, look. Y is equal to 3 is a horizontal line passing through y is equal to 3. So let's just draw that line on. And where does that line cross the curve? It crosses here, look, and here. So what we want is the x values of those 2 points where it intersects. So we're just going to drop a line down from those points of intersection down to the axes. So I can read it off nicely. So there, I think. Okay, so I want those 2 values there and there. Now on this graph we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now 10 little divisions between there and there, just double checking. So I'm 4 little squares up from 0 then. So that left limit then is going to be x is equal to 0.4. That's 0.4 there. And then up here I've got 2.1, 2, 3, 4, 5, 6. I think that's about slightly to the right of 2.6. But I'm just going to go for 2.6. I'm going to round it down to that one. So 2.6 for that. Taylor designs a logo using isosceles triangles joined at a central point P. This is the start of Taylor's design. The complete design will have rotational symmetry of order 60 about point P. Each triangle has base B and height h measured in millimeters square in millimeters. Calculate h when B is 40 millimeters. Give your answer to 1 decimal place. Okay. Now, if this is going to have rotational symmetry of order 60, that means you're going to get 60 little triangles all the way meeting down at point P, isn't it? So that they look the same in 60 different positions. So that means that each one of these angles here is going to be 60th of a full turn, then, isn't it? And that's going to be 360 divided by 60. So each one of those is going to be, what, 36 over 6 is going to be 6 degrees, isn't it? So each one of those is going to be 6 degrees. So that's a 6-degree angle there. Okay, so knowing that's a 6-degree angle, but what we can do is we can use right angle trigonometry, just using like half of this triangle then, isn't it? Because we know that's 6 degrees there. And we know that the whole length is 40, so up to the halfway point is going to be 20 because it's an isosceles triangle. So that H line kind of divides the triangle in two. So what we need to do is to find this side here, H, don't we? Okay, so we've got the, which side? We've got the adjacent, haven't we? This is the adjacent side, and we want the opposite. This is the hypotenuse, the longest side, opposite the right angle. We don't want the hypotenuse, don't really care about the hypotenuse. So thinking about SOHCAHTOA, all the ones with H in it, we don't really care very much about because we don't want H. So that leaves us this one here, tan. Tan equals opposite over adjacent. So the tan of theta is equal to the opposite over the adjacent. Okay, so, and we worked out that the angle is 6 degrees. So the tan 6 is equal to the opposite, which is H, that's the thing we're trying to find, divided by the adjacent, which is 20. So then the height of this is going to be 20 tan 6. Okay, and what's 20 tan 6? 20 tan 6, that comes out to be 2.1-ish. So that's 2.1 then to the nearest decimal place. So that's my answer then, 2.1.
Mr. T, he's the best, helps you ace